All right, now let's just talk about the organization of the periodic table. We have, so we're going to talk a lot about how it's organized. We've got groups and periods. All right, they're made up of groups and periods, so they're currently 118. You have vertical columns, all right, which are up and down, and you've got horizontal, and the vertical are called periods. Okay, so the vertical, so you notice that there's a vertical box right here. All right, this is a period. So here's period 1. Period 1 is composed of hydrogen and helium. Period 2, from lithium to neon. Period 3, sodium to argon. Period 4, potassium to krypton. Period 5, period 6, and finally period 7 goes from francium all the way to UUO. I am not saying the the number. I believe that's Latin. Those are the Latin names for those. Okay, a few of them have names. Okay, so those are periods. Groups are up and down. So here is group 1. Oh, that was group 1.5. All right, so here is group 1. Here is group 2. You can even see the numbers. All right, so group 3 is this whole group. My goodness. Group 4, group 5, group 6, group 7, group 8. Then you have the B's. The B section, yeah, they're groups, but notice they're weird. They start at 3, and then they go to 12. We're not really going to worry about the group numbers for here, but the A's are what's called the, they're very common. It's the main group elements. Main group elements. All the A's. All right, the B's are called transition metals. And these down here, which aren't here, but these are called the inner transition metals. All right. So you have the main group elements, which is really what we're going to talk about, a lot of those. The transition metals is this area in here. All right. And then you have the inner transition metals. But pretty much you have groups, which are up and down, and then you have periods, which are the horizontal across. Okay. Oh, that's weird. Why aren't we erasing? Oh, there we go. That was weird. Okay, so organization. Now, each of the groups have different names to them. So the group 1As are called alkali metals, okay, excluding hydrogen. Hydrogen is a non-metal. I had a teacher once say that the hydrogen is kind of its own periodic table. Sometimes you'll see a hydrogen on a periodic table right in the middle, right here. And it's because it does things way different than any other elements on the periodic table. Okay, so hydrogen's kind of in its own league. All right, so the 1As, so starting from lithium all the way down, are called alkali metals. Okay, you have to know these names. Group 2 are called alkaline earth metals, so beryllium down to radium. Okay, group 6, we jumped to 6 because 3, 4, and 5 don't really have names, so group 6 are called the chalcones. I'm sorry, the chalcogens. All right, so that's what group 6 is called. Group 7, this one is not very common. Know it, but honestly, guys, I'm probably not going to test you on it, okay? But yeah, you might come across it. Group 7, however, the halogens. You've heard of halogen lamps, all right? It's because they are made up of fluorine, chlorine, bromine, and iodine, all depending on the color, okay? If you've got like a yellow color light, it's because of fluorine, or green is chlorine. Bromine kind of has a brownish tint, or brown red. Iodine has a purple color. All right, so these are called halogens. And then you have the noble gases, which are also made up of lights, like a helium lamp. You guys have seen helium is a red color. All right, these also change colors. I think krypton is a blue color. I'm sorry, purple color. All right, so you've got the alkaline earth. All right, the halogens and the noble gases, and the chalcogens, if you want to know. I'm sorry, yes, whatever. If you want to know it, that's fine. You will not be tested on it. Okay. Now, the table is also composed of metals, nonmetals, and something called metalloids. So let me go back to this periodic table, the one before it. All right, so like I said, you've got metals, nonmetals, and metalloids. All right, now it says the periodic table is divided into metals and nonmetals by this diagonal zigzag line. I will show you where that is. All right, metals are located on the left of the line, nonmetals are on the right, and the metalloids are pretty much on the line. Okay, so that line, if you have your periodic table that you printed out, if you don't, when you do print it out, you might want to put this line on there to help you kind of study. And when we go into class, you'll kind of see that the line, I think it ends there, but we can put it down here. All right, this is kind of the stair step, and you can kind of notice the color of the elements, the orange color. They're doing that because those are the metalloids. There's only, I think, 11 metalloids, 2, 4, 6, there's 8 metalloids. Okay, so this is the stair step case. Everything to the left are metals, with the exception of hydrogen. All right, so lithium, beryllium, sodium, magnesium, chromium, Tl, UUT, Fl, Pb. These are all metals. Everything except hydrogen, everything in here are considered metals. Okay? Everything to the right are non-metals. Non-metals, they are not metals. So you can see there's a lot less non-metals. These are all the non-metals in here, all the blue, the darker blue. Carbon, nitrogen, oxygen, fluorine, chlorine, sulfur. All right, so, and then the red one, I'm sorry, the orange ones, there are 1, 2, 3, 4, 5, 6, 7, 8, are what's called metalloids. Metalloids. They have both metal and non-metal properties. All right, and depending on the side that they're on, they have more of those properties. So notice things on the right side, boron, silicon, arsenic, tellurium. These have more kind of non-metal-like properties, especially boron and silicon. Arsenic, yeah, I mean, it looks like a metal, but it behaves more like a non-metal, which is kind of interesting. Okay, and then things on the left side, antimony, germanium, polonium, kind of have more metal-type properties. Okay, so you have 3 different types. You've got metals, nonmetals, and metalloids, and they are separated by the zigzag line. Okay, so here we go. Identify as metals, nonmetals, or metalloids. Now, for most of these, you might be able to figure out. Some of them you might have to look at the periodic table. For example, nitrogen. Okay, everyone kind of knows nitrogen is a gas. There is not a metal, nitrogen. So everyone kind of knows that nitrogen is going to be a non-metal. I'll put NM. Okay, silicone. You might just know because we just talked about it, but if you don't, look at the periodic table. Notice that silicone is right on the line. So what does that tell you about silicone? That it is a metalloid. I'll put Ml for metalloid. Calcium. Calcium is a metal. How do I know calcium is a metal? Here's calcium. It's to the left. You know, a lot of people think, well, how can calcium be a metal? Because, you know, my bones are made of calcium. All right. Well, that's your bone is not calcium metal. Your bone is made of an ionic form of calcium. It's called calcium carbonate. There's also calcium I can't remember the gly part of it, but anyways, it's composed of an ionic bond of calcium, a different form of calcium, not calcium metal. Chlorine is a nonmetal. All right, how do I know? Because chlorine is right there. And then finally, arsenic. That is one of the metalloids. How do I know? It is right there in the orange form, or I'm sorry, orange color. Okay. So fine. So we just did that. All right. Another interesting thing, so we did the elements of the human body, now let's do the elements of the planet. And look what is the most abundant. Pretty interesting. Our bodies are most abundant, and Earth is the most abundant. That might be an evolutionary trait, if you think about it. All right, it actually is. The reason why we are so composed of oxygen is because our planet is composed of oxygen, again, in the form of water. So this is kind of showing you that evolution, that we have evolved from our planet, which has had a huge amount of oxygen, which is why we have a huge amount of oxygen, or kind of implies that. All right, and then you can see a few of the other elements. Silicone is actually pretty large. A lot of people are like, silicone, what? How does that kind of. Silicon is in sand. All right, sand is silicon dioxide. All right, glass is silicon dioxide. So our planet is composed of sand and dirt and rocks, and all of those have silicon dioxide in them. So that's why silicon is a really hugely abundant element. Okay. Next, looks like aluminum is pretty high on there. Iron is pretty close, and calcium, sodium, potassium, magnesium, and then obviously all the other trace elements. All right. So kind of interesting to see the Earth's core. We're going to stop right here, and we're going to pick up on isotopes on the next video.